Today we are going to graph exponential functions without plugging them into our graphing calculator, although that's kind of a lie because we're going to use the graphing calculator to help us, but we're not going to type the whole thing into the graphing calculator. We're only going to use the graphing calculator for part of it. We are looking at the graphs of exponential growth and decay functions. Exponential growth functions are equations like y equals 2 to the x. Exponential decay functions are something like 1/2 to the x. We're going to talk more tomorrow about the difference between exponential growth and decay, but we'll kind of mention it as we do these examples. So an exponential function involves the equation y equals b to the x, where the base b is a positive number other than 1. An asymptote in these graphs, they either look like this, or they start really big and then get small. The asymptote is the line that the graph approaches and gets closer and closer and closer to, but doesn't actually touch and doesn't actually cross. The graph of y equals a times 2 to the x does have certain characteristics that are worth noting. The first thing is that the graph passes through the point 0a. So whatever number is multiplied in front of the exponential growth or decay function, that is going to be a point on the graph, 0a. That means that the y-intercept is a. And that's a handy thing to know so that as you're graphing these, you can kind of check to make sure that you did it correctly. The x-axis is an asymptote of the graph. The domain is all real numbers. Sorry, that's so dark on your notes packet. And the range is y is greater than 0 if your a value is greater than 0, or y is less than 0 if your a value is less than 0. Basically, the rule here is if your graph is on the upper half of the graph, your range is y is greater than 0. If a reflection has happened and your graph is on the lower half of the graph, then your range is y is less than 0. So if there has been a reflection over the x-axis, if there's a negative number in front of the function, then that switches your range to y is less than. When we're graphing y equals a times b to the x minus h plus k, we're going to start by looking at a temporary graph of everything up to the x. You stop after you get to the x. So I'm going to kind of write out my steps for this first one. Start with temporary graph. Y equals 3 times 2 to the x. Notice that I ignored the +1 and the -4 for now. So you're looking at everything up to the x. Once you get to the x, stop and ignore everything else for now. This is the function that we are going to use in our table of values. We're going to put in x values, plug them in, find values. I will graph these on the graph using tiny little x's. Then the +1 and the -4 tell us how this graph is going to move. So what does that +1 and -4 do to the graph? Left 1 and down 4. And I will draw in the final points that have been moved left 1 and down 4. So we're starting with a temporary graph that doesn't have any translations. Then we translate the graph, and that gives us our final graph. So back to the temporary graph. Some good numbers to use in your x column are -2 to +2. If you have a scientific calculator, all you have to do is 3 times 2 raised to the -2. Plug each of these numbers into this temporary graph equation. So 3 times 2 raised to the -2, 3 times 2 raised to the -1, 3 times 2 raised to the 0, 3 times 2 raised to the 1, and so on. but would you maybe like a shortcut? Okay, if you have a graphing calculator, you can make your calculator do all that math for you. I just have to wait for my calculator to pop up on my screen here, which sometimes takes a while. I honestly don't care about the graph feature, but in the y equals button, you can enter this temporary graph, and then the table will do all of that math for you. So if I plug in 3 times 2 raised to the x, notice I still did not put in the plus 1, I did not put in the minus 4, I'm only putting in the temporary equation. I don't even click graph, I go straight to the table. Second graph button to look at the table. This tells me that if I plug -2 into this function, I will get 0.75 as my y value. If I plug in -1, I will get 1.5, and so on and so on. So record these values into your table. So -2.75, I think that was 1.5, 3612. Okay, really my goal this year is to show you how many amazing things there are on the graphing calculator to encourage all of you to buy one if you don't already have one. As long as you get a TI 83 or higher, you should be fine. So even if you go on eBay or Craigslist and get an older calculator, the older calculators still do this feature just fine. I'm going to plot these temporary points on my graph. So -2.75, -1, 1.5, 0, 3. Notice that it crosses the y-axis at 3, and 3 is the number in front of that equation, so we know we did that right. 1, 6, and 2, 12. Each of these points now needs to be translated left 1 and down 4. So in purple, oh my goodness, what just happened? In purple, I will move each of these left 1 and down 4. Because we moved this graph down 4, I would strongly suggest that you circle down 4 and write asymptote underneath it. So down 4, there's going to be a horizontal asymptote, and when we draw in our graph, we cannot cross that line. So it's a good idea to draw that in with a dashed line, just that you have like a barrier for yourself. And then connect these points. Now we need to think about the domain, the range, and the asymptote. The domain's the easy part. Anyone know the domain? All real numbers. Okay, the asymptote, I'm going to skip down to the asymptote. Do you see how we moved this whole graph down 4? So the asymptote is y equals 4. Sorry, -4. You're right, -4. The range and the asymptote are very, very linked. Your range is going to be y is greater than -4. If your graph is above the asymptote, your range is y is greater than the asymptote. If your graph is below the asymptote, your range is y is less than the asymptote. On this next graph, we would start with the temporary graph. Y equals 2 times 3 to the x. This is what you would plug into the graphing calculator, or this is what you would plug x values into to get your temporary points. So I would put 2 times 3 to the x into the graphing calculator, look at the table, and see which points would be easy to graph on that table. Then each of those temporary points, now we look at the stuff in the exponent and the stuff after. Each of those points would then be moved. What does the -2 in the exponent do to the graph? Right 2. The +1 moves everything up 1. Because we're moving this graph up 1, that determines the asymptote. So our asymptote would be y equals 1. That means that our range would be y is greater than 1, assuming that this graph was on the above the asymptote, which it would be. Okay, let's turn to the next page and do an example with a negative number in front and a fraction, just so you can see what happens with those. Your temporary graph is going to be y equals -2 times 1/2 raised to the x. Anything that comes after that x, just ignore it for right now. That's how you're going to move the graph after you get your temporary points. And I'm going to go ahead and write that in. After we've graphed our temporary points, what does this +1 in the equation tell us we're going to do? Up 1. Notice there's no side-to-side movement. There's just up 1. And up 1 is also going to be the asymptote. I want you to make the connection today between vertical movement and the asymptote and the range. The vertical movement, the asymptote, and the range are all completely linked together. So if we're moving up 1, I'm going to go ahead and draw in a dashed line showing that my asymptote moved up 1. If we're using the graphing calculator trick to make the calculator do the math for us, we punch in -2 parentheses 1/2 or 1 divided by 2 raised to the x. Go straight to the table, and the question I commonly get is, how do we know which x values to use? Should we always use -2 to +2? Could we use -1 to +2? What x values should we use? I like to look at the table and think about which numbers could I fairly easily graph. So -2, -8, I can definitely easily graph that. So this is -2, that looks like -0.2, -2, -8, -1, -4, 0, -2, 1, -1, 2, -0.5. So see how I'm using that portion of the table. If you were to do this and you got the point -2, -50, you can't really fit that on your graph, so you'd ignore that point and then move to a different place on the table where you could actually graph those points. Okay, graph these temporary points. I totally wrote those in the wrong table, didn't I? I'll move those over, but graph these points on that first graph. Okay, once you have the temporary points in there, we're going to move each of these temporary points up 1. And then think about your asymptote. Make sure that when you draw this graph in that you do not cross that asymptote. The domain is easy. The domain is all real numbers. The range and the asymptote and the vertical movement are all linked together. So because this graph moved up 1, the asymptote is y equals 1. So our range has to do with y and 1. Do you see how our graph is underneath the asymptote? It's on the bottom part of the asymptote. So it's y is less than 1. So you may want to write yourself a little note that if it is above the asymptote, your range is y is greater than the asymptote. If the graph is below the asymptote, your range is y is less than the asymptote.